Are you looking for?
I'm looking for Robert.
I'm here. I'm just sitting.
Hey! You guys have a clicker?
What?
The clicker for the slides? Anything like that?
No.
No?
Sorry.
Pointer clicker? No, right? Okay. Okay. Alright. Everyone settle down. Great. Okay. Welcome guys to Ruby Tuesday number 49. Hey, give yourself a big round of applause. Let me know if this is still
This is the TM connection, but we have a time connection now, so it's uppercase.
Oh, it's there?
Yeah.
Oh, it's uppercase. Okay. So, alright. It's here, okay.
And the password's uppercase.
Password is the same. Yeah. Alright, let's get things started. So, this event is proudly brought to you by Surya Labs. Here, and of course, yeah, and we are the KL Ruby Brigade. Wi-Fi is Surya Labs. How many first timers?
Second time.
Welcome. So, if you guys don't know, we are on Facebook groups/KLXRB. We also have a website called rubybrigade.my, which redirects to the Facebook group. We also recently on meetup.com, so to increase our SEO searchability. And we are at meetup.com/ruby-malaysia. Will we soon include the the Penang chapter, right? We also have a GitHub account, so there's some cool fun projects that you can look at github.com/klxrb. We're also on Slack, so our Slack channel is Ruby Malaysia, Ruby My. You can invite yourself there by going to rubybrigade.my/Slack_invite, or the bit.ly link will be my Slack. And hi, I'm Jimmy. If you guys don't know me, I'm Jimmy. I'm usually the host. So if you have anything you want to feedback to me later about this event, feel free to do so. Oh, crap, I forgot to put this thing out. Sorry, Carlos. What? You didn't remind me to.
Yeah, we got here, there were many people around and got distracted.
Sorry.
Oh, name tag.
Name tags. So anyway, yeah, forget about it. But just remember to introduce yourselves to your neighbors over a beer or a pizza later. And there's also this 5 Ruby tips at the end of the talks, which is open to you guys. So if you have anything you want to share to the crowd, you can come up here for however long you need to show off this tip at the end of the talks. So if you have something in mind, prepare that, and I'll call upon you guys after talks. And so without further ado, wait, before that, okay, so we have some hiring shoutouts. So Clickboard is hiring front-end developers, and on a full-time or part-time or project basis. So if you're interested, look for GUI over there. And now, finally, without further ado, let's get on to the talks. So we have 3 talks for you today. Number 1, we're building P2P network with Ruby. This is by me. The second one will be a public repo private key. I hope I got this right. Yep. Public repo private keys managing sensitive info with RSpec and VCR, done by Nick over here. And lastly, there's gonna be a talk about API documentation with Striker, my GUI. So let me start. Oh, is it?
Shall we turn it off?
Can you turn it on more? It's hot.
It's hot.
Yeah.
19.
know how to set up the mod. Never mind. Okay, let me start then. Okay, so let's start with my.
Do you need a chair or something? A chair?
I guess I can. Let me try sitting down. Okay. Now, so let's start. So I'm gonna talk a little bit about peer-to-peer network. And again, hi, I'm Jimmy. I'm an engineering team lead at Rapid River Software. This is my boss over here. This is my other boss over there. So I run here Ruby Brigade and also sometimes run Ruby conference. And I love Ruby. So there's a reason why I'm learning this. If you guys have been following the recent Ruby Tuesdays, I've been talking a bit about blockchains. So a big part of blockchain is the network. Yeah, because it's where all the consensus come from, it's where all the mining comes from. So I was kind of going to figure out how it works. So that's why I was learning this. So first things first, if you guys don't know, peer-to-peer is just a type of computer network which is basically distributed. The idea is to share workloads across the network so that workloads can be shared. There's preferably no central administrative device. So preferably everyone knows what to do and knows how to make the whole network thrive and survive. But sometimes you see that it's not always the case. And some popular examples are, for example, Napster. If you're old enough, you probably know this. Nutella or BitTorrent. So this is these are some of the popular P2P clients. I forgot to put. So never mind. So usually P2P, most commonly you can see used for file sharing, because when you download a file from a central server, there's a bottleneck. If too many connections connect and download from the same resource, then there's a bottleneck that it will cause delay. So, but if you're in a distributed network where files are shared across, then everybody is a source, everybody is a seed, and therefore it makes things go faster. Therefore, file sharing is a very good or very common use case of a peer-to-peer network. So in a peer-to-peer network, you can see terms like nodes on peers. Nodes are just computers on the network, and peers are just nodes that kind of know each other. So if you know about another computer or another node, then you are his peer and he's your peer. So that's just the terminology here. And of course, if you go into different implementations of peer-to-peer network, like for example, file sharing system, then you have leeches and then you have seeds. So, but that's just different implementation. But in general, nodes and peers. So, if you look at types of peer-to-peer, there can be a few. So, like I mentioned before, the purest one will be the one that have all the nodes acting like clients or servers and servers. So they all know what to do with each other, they communicate, and they don't need anyone telling them what to do, or they don't have a central administrative system. So there's no central server, there's no central router. This is a pure peer-to-peer. Another one, which is more common, is that there's a centralized server with peer information. So of course this information differs from types of networks or types of implementations. Some of them carry a lot of information. For example, in Napster's case, which we'll see later, it actually stores all the peers, all the files, information, where they're stored. So these are heavily centralized. On the other end of the spectrum, you have some centralized information. So for example, some of the seed servers that is required to do the initial network discovery, those will be centralized and centrally administrated. So again, the peer is the one heavy work, doesn't do the organizing or the directing traffic and those kind of things. So these are the hybrid methods, and the mix is just pure and mixed characteristics. So again, I pulled this off some website to sound clever. But anyway, so let's look at Napster. So Napster is probably one of the earliest peer-to-peer network that is popularized, obviously by pirating stuff over the internet. So we can say that this is considered a first generation type of peer-to-peer network. Like I said before, it actually has a central server. Actually, it has a couple of central servers that stores all the node IPs, all the files that are stored on those nodes, and shared on each node. So therefore, it's very easy to take them down. But this is considered one of the first generation of peer-to-peer server. As you can see, it's not really a pure peer-to-peer network because of this nature of things, nature of control and information heavily central around certain nodes. Number two is example here from this file sharing service called Gnutella as well. So this one does not require this kind of network does not require a central administrator or central directory of the nodes of the file system. It does it all by themselves. The nodes discover the network all by themselves. So, and the way that they do this is by just flooding the network. So if they know a few of the networks, a few of the peers that they are connected to, they will just flood them and ask them to flood and flood until they find the file that they want, or until they hit a range limit that is desired. So again, you can see that this is probably very inefficient because it requires the node to kind of go through the entire network to figure out where are the files that they want, and where are the peers that, what are the IP address of the peers that they need to connect to. So, so this is second generation. So the third generation is more like what we have today with BitTorrent trackers. So they usually implement something called a distributed hash table. So there are many, there are a few implementations of distributed hash tables. I will show you one later. So in general, it's just a very efficient way to store information about the file's location and distribute it to the network. So the idea is that with this distributed hash table, you don't need to discover all the nodes in the network to find certain things. The hash table is done in such a way that you only need to go through, or the information is widely available enough that you can go through a few nodes or lesser nodes to figure out where the data is stored. So, but again, there are many papers and videos explaining how this works, and frankly, I don't really understand that deeply into how the distributed hash table works. But yeah, there are a lot of videos and resources you can take a look at and and find out how this works. But yeah, usually nowadays the peer-to-peer network uses DHTs. So this also creates a very nice effect that when nodes join and leave the network, it doesn't impact the network as much. In a way, because of how the hash table stores bits of the data. So you can see here that the data is basically hashed. The chunks of data are hashed and distributed. The information of the data is distributed throughout the network. So if you have the file and you have the same hash, basically you can get the same data from me as long as the data is the same. So obviously, because the data is the same, then the hash is the same. So using hashes, this kind of makes it easy for files to be shared around and chunks of files to be shared around. And yeah, again, you can take a look at it more deeply on other videos and resources. Okay, so how does this work? This all this whole like discovery and then sharing and hashing. So the primary mode of operation is for the nodes to have a way to execute procedures on another node remotely. So by implementing an interface for remote procedure calls. So in this instance of an example of distributed hash table networks called Kademlia, the white paper or the idea is to have all the nodes able to respond to these 4 RPCs, and of course you can implement more depending on what you want your network to do, but with just 4 of these RPC calls, the Kademlia network can easily find and discover peers and discover the data and where they are stored through the data through the hash table. So this is one of the ways that peer-to-peer network with DHT structure uses RPC call to discover the network. And for Bitcoin Core, it basically also has an RPC interface. It has these RPC methods that you can see here. If you go through their source file, you can find out in the RPC folder what types of command that a Bitcoin node actually accepts. So for example, it can actually get network info, get blockchain info, get wallet info from any of the nodes. And for example, there's also some RPC for mining. So if you look at it, for example, this is the RPC documentation, RPC source code for the Bitcoin Core. You can see that for blockchain, it has a few dozen RPC calls that basically this is the blockchain RPC, so obviously it does something to, you can ask it to do something with the blockchain. So again, for say the mining RPC, you can see that for the mining, you can ask the node to give you to estimate a fee or to get the network hash or mining info. So basically, through RPCs, the work is done through having this RPC enabled throughout the network, and each node kind of tells each other what it needs to do. So this is peer-to-peer example with Ruby. So another interesting thing was discovering, I was reading about this, is that there's a guy, there's a team that actually built a peer-to-peer file sharing system with Ruby called Zoro, and this is pure Ruby implementation using the Kademlia DHT strategy. So unfortunately, I couldn't get it to work on my local. But again, this go to their website, those that GitHub pages. There's a pretty comprehensive video and also tutorial on how to set this up. But the interesting thing is, of course, this whole thing is open source. Oops, what? It's open source, so you can also take a look at how things are done. There's a video of this guy talking about the Zoro system on YouTube, so you can take a look at that as well. But let me show you just a little bit on the GitHub source. So again, I feel I like to go through the source code because sometimes I find like very interesting things. Like for example, I posted a question on the Facebook channel about the concurrency Ruby library. I found it here and found it implemented here. So you can see here that there's this is how a Zoro node is defined. So the Zoro node, when initialized, it will connect to the network, and the network is basically seeded. So example, you have to create like a first super node, so to speak, to let other network connect to you. So in this case, it's a hosted Zoro server on their domain. So you can set username and password. So that means you can set up a private peer-to-peer sharing environment. So you can set up your supernode with your username and password, and you distribute that so everyone else can connect to that same network. So again, that supernode is just to facilitate the discovery of the network, so everyone can discover each other. But the file itself is always going to be shared and copied over from peer to peer. So you can see here that there's a few methods to see how we can see that there's a broadcast, so meaning that this node is supposed to broadcast something, you know, when state change, when something's changed. And for example, it generates a bunch. I want to find the part where it creates the file manifest. So alright, I guess I didn't find the part. So Zoro here, when you upload something or you put something into your folder that you've set to be the shared folder of your Zoro node, it will basically take the file and split it into 1 megabyte chunks. And then it uses a hash method to find the hash for these chunks, and that's stored as a manifest for the file. So to define a file, it has a manifest that has all these hashes, and that manifest file is what gets distributed throughout the network. and basically that's how the node will find the shards of the file as well. So I know it's pretty boring without a demo, so I'm gonna just stop here. I hope you guys can go and take a look at the project. It's pretty interesting, and yeah, that's where I found the concurrency Ruby library being implemented. So again, that's all I have to share today. The references for the information I got here mostly are from Wikipedia and the internet, but most prominently, take a look at the Bitcoin Development Guide P2P network description. It's pretty interesting how they outline how the Bitcoin network works. You can see here how the peer-to-peer network should be structured and what kind of how the peer discovery works. And you can see here that the Bitcoin core network is using the seed network, the seed node methodology. So once you actually download the Bitcoin core node and you run it, it actually pings a few of the build of the DNS server that is built inside the code to find some up-to-date recent IP addresses of the nodes. Then you connect to that one, and then it asks the nodes to give you the list of the peers that they have, and therefore you can find out more nodes. So this is how the peer-to-peer. So this is how Bitcoin core discovery, peer discovery works. So you can read a lot about this very interesting how they're connecting to the peer, and things like that. And of course the Zoro project. So yeah, that's it from me. So any questions? No questions. Okay, then if no questions, thank you very much. So Nick, you want to go?
That discovery, yeah, sounds like a good application of DNS.
Yeah, really?
Yeah, well, if you want to take over that network,
Yes.
you just spoof those nodes,
Yeah,
spoof those entries.
gives
in
you
the
like
DNS.
90 euros.
Yeah, and then you're just like, no, it's my network. In my network, all the money goes to me.
Yes.
Okay, gonna close all my Pornhub tabs.
Also, we had some good yellow. Okay. Full yellow, then I sound good here, but after I recorded it, it's crashing. Yellow, all is getting yellow is fine.
Let me just connect to the Stereo Labs network.
So I've been tweaking it on fine.
Okay. A lot of MacBooks. Okay. Okay, hi. I'm Nick. With Legs. I'm way too fidgety to sit down while talking. So, this is a little bit sort of the other end of the spectrum of things to talk about. This is a sort of practical thing you might want to know if you're working with Ruby and VCR. And it's about the problem of managing public repos that have private keys. And specifically, what I want to talk about is the special case where your private keys might get exposed through VCR. So I'm going to talk about what all these things are if you don't know what they are. So just say who you are. So I'm Nick Martin, and I work at Rapid River Software. That's our logo. It's tattooed right here on my leg. I'm fucking serious. So you're French. So what's the motivation here? So let's imagine you have an open source repo, or you want it to be an open source repo. That's actually the angle that I came at it from. I work for a government project called search.gov. We handle all the information searches for the US government. We have, something like 200,000 users or something a day. And we have our main monolithic application is written in Ruby, and it's currently closed source. One of the really the last remaining reason why it's closed source is because embedded in the code base are all of the keys that we use to interact with other services. So for example, AWS S3, we need to run unit tests where we interact with AWS to verify that we can upload images. Those keys, I don't want the world to have them because boy would our AWS bill go up, right? So our integration tests use VCR in order to reduce our interaction with AWS and other services, but those keys are stored in the repo. So if we were to just open source that repo tomorrow, we would get a lot of valuable contributions from the community, and we also would be paying like $1 million a month to AWS. So my motivation is to keep small changes really easy to test without any secrets whatsoever. But I also want the ability to run the specs for real against the actual external services when the time is right to do that. So in other words, I want to preserve my ability for VCR to be disabled and to actually talk to remote services. But by default, I want a developer experience where you can run all of our specs without ever talking to any real services. This is really what VCR is for. But in this case, we're talking about VCR that involves private conversations. So it's kind of a hard problem. So hopefully you'll find my answer to be fun. Okay, so what's VCR? It's located at github.com, the VCR organization. It's a big deal in Ruby if you haven't used it. It intercepts requests to any remote HTTP endpoint, and it saves it in a file. And then in a future time, if in your specs you try to contact that endpoint again, the response gets played back out of the file instead of a real network request taking place. So this reduces spec runtime because your specs aren't going out to the network. It increases spec reliability because if that endpoint service is down, you're now interacting with a successful version of the conversation rather than a 500 error because they're down for maintenance at 11 o'clock at night on Friday night when you're coding, because that's what we do. It's very, very configurable. It's really an awesomely mature library. So you can, for example, say skip certain sites. It does not make sense at all for me to record requests to localhost, right? Because that means I'm talking to some local server, some other microservice, and I want that conversation to happen because I want to make sure my microservice is working. And it also lets you write custom matchers. So I'm going to talk about this example in a second, but Paperclip. How many people here have used Paperclip to upload files? Has attached file, right? Okay, everybody, right? So a pretty common thing when you generate a Paperclip attached file is you need to give it some path that exists out on the internet. So you put :ID, right? Well, what value does :ID take on? Who knows? Roll the dice, right? So if your VCR config looks at the URL to see if it should play back that request, well, the ID is different each time that you upload another file, and so you don't get a match, and you go talk to S3 again or whatever. So custom matchers are something that allow you to say, look, this URL really looks good enough to be used for this URL, so please use the conversation that was recorded in the file. I encourage anyone who hasn't used VCR to learn about it. It's an amazing library. But we have this problem. So, I'm sorry, time out, get ahead of myself. Let's take a look at what a VCR request looks like. Okay, so thanks to Skitch and this huge TV, it should be really easy. It records everything in a YAML file. Everyone knows how to read YAML. If you don't know how to read YAML, you now know how to read YAML. It's really readable. So in this case, we have a request. I work on a government project for the US government, so consumerfinance.gov back in the day before they started gutting the whole government. Donald Trump is a website that tries to help people, which is the thing we used to do. And so there's this page about consumer tools auto loads, and so this is the full URI for the page. If the request that you make in your spec matches this URI end method, right? Because we all know methods are very important. If it was a post or delete or something, this wouldn't really be the same conversation. I think that's actually what Donald Trump did, delete. So if the request is the same then the response headers can be played back, right? You want the same E tag, you want the same status code, content type had better be the same. And also, very importantly, this extremely readable body should also be played back because you're expecting that to be your conversation, right? And so now, as the spec VCR caller, it's as if you talk to consumer finance and it hadn't been replaced by a picture of Steve Munchin just laughing at you. Okay, so what's the problem with this? The problem is quite simply this. Now this is not actually, this foo here replaces actual sensitive data. So you have like 2 to the 80th combinations to go through to get my actual key. But if you record a private conversation and your credentials are embedded in it, that's a VCR cassette you can't commit to a public repo, okay? This quite simply is the problem. Yikes, okay, can't do that. Also, that's not valid base 64 binary, I truncated it. Okay, so in summary, it's really hard to stub the behaviors of complex APIs. VCR lets you interact with the remote service once and save the results, but the VCR cassettes contain sensitive secrets and that can't be shared with other developers. Therefore, the kibosh on the whole open source thing. Oops. My wife's calling. Sorry, huh? Okay. She's in America, she's not. Okay, so the solution really generally is that we want to use VCR's filter-sensitive data method. It's a really well-named method, filter-sensitive data. And so the way that we do that is we say, VCR.configure, this is sort of a class method, and it gives us an object where we can call other class methods. And so we might say, I want, anytime you see my AWS access key, this value, sensitive thing right here, I want you to replace it in the cassette with literally, greater than sign, or less than sign AWS access key, greater than sign. And that can go into my file, and everyone can see that because they should know that an AWS access key goes here, and that's fine, right? So that's really nice that VCR has that. This is not the end of my talk. It's going to get more interesting. Okay. Okay, great, awesome, right? So now my file, all this sensitive info, I'm not sharing with people anymore. Okay, great. But now all I've done is I've just put the secret somewhere else. I also have to commit that file. And I have a lot of secrets to manage, so who wants to type like filter sensitive data a whole bunch of times? So I don't want to think about this ever again. I just want it solved. Like, can we just get a solution to this? Well, as it turns out, we can. There's this thing called config-secrets.yaml. It's an absolutely fantastic place to put secrets. Now, of course, you're probably thinking, Nick, you didn't solve the problem at all, because config-secrets.yaml is in your repo. Well, not so fast. Let's just think about config-secrets.yaml. What can we do? Well, let's start with the premise that secrets are secret, right? The first thing I'm going to do, I'm going to put secrets.yaml into my gitignore. So from this point forward, what's in secrets.yaml is not going up to GitHub, okay? What I'm going to really commit is actually a dummy file. We'll see in a second. But that file, from now on, when I make changes to it, Git is just going to ignore those changes. That's great. Secrets.yaml should actually be telling us which secrets are secret, which is a weird thing to say, but I actually mean that you should break out a different section of your secrets.yaml, call it secret keys or something, and put your actual secrets in there. Now, this is not the one we're going to commit to GitHub, okay? It's the one we're going to use for our specs. And if you guys notice, those of you who for some reason aren't familiar with YAML references, my actual secrets are going to be here in this section, and I'm going to name this section, all caps, secret keys. So that means down in my development and test environments, I can just include that by reference by saying inherit star secret keys, okay? So that means for development and test, I don't need to type things twice. All the good bits are up here. But why did I do that? Well, it wasn't just to avoid typing. It's because I also want this section of the file to tell me which things need to be replaced in VCR. So I've actually broken out a top level entity in my secrets.yaml that's the stuff that I really want to do this with. I call it secret keys. The secrets know they're secret, so they'll stay secret. So I write a VCR configuration where I load the secrets.yaml. Anyone want to raise their hand right now and say, but Nick, you can just use rails.application.secrets. Well, no, you can't. Because if I'm in the development mode and I type rails.application.secrets, which section do I actually get? I get this one, right? I actually want specifically the section that said it was all secret stuff. What's not obvious in this example, and I apologize, is I could have other keys in the development section that are not part of the secret keys. The secret keys section is the one that's really what's going to be masked from everyone. So I actually pull that entry of the YAML file out, and iterating over this in classic hash iteration style, I take the name, I take the value, and I do some interpolation magic, and I generate a name, such as AWS access key ID, right there. Now upcase it, this upcase is nice and easy to identify, and the block that I pass to it is just the actual value of the key itself. So that's it, that's your whole configuration. So where do the real secrets go? Well, they don't go into config secrets.yaml. Put them in a separate private repo. You write them down on a piece of paper and you edit your secrets.yaml when you need to. You do like Dan Brown and you hide them in a series of like religious artifacts all around the city of Venice or whatever. You don't put them in your repo, right? You only put the secrets into your secrets.yaml file at the moment you really want to re-record specs. So you have that aside somewhere else in the correct form. You just copy it into place when you want to fully re-record your specs and then you move it aside. What actually gets committed into GitHub to share with other people is dummy values. Doesn't matter what they are, because whatever they are, they're going to be matched by VCR when you run your specs. Okay. So this you can safely distribute to the world. These aren't real. Okay. So you may think, well, like, oh, danger, danger, Will Robinson. Like, what happens if I put my real secrets into the file, re-record, and then I push that to GitHub? Well, Gitignore is supposed to prevent that. So if you find a way to push your secrets to GitHub in that situation, you're a moron, and I can't help you. Okay. So that's it, right? We're not done, actually. If you start with a private repo and you make all these fantastic changes and you push that up there and say, it's open source, all of your old commits are still in that repo, okay? So that's not good, because anybody who knows how to do git reset now has all of your old keys, right? So as a one-time thing, if you're going to try to take this approach with your project, you really should delete the .git directory and do a git init and re-add everything, and now push to your open source repo with none of the history of what your keys used to be. Okay? The other problem that you'll run into is that a clean URL is not equal to a unique URL. And I mentioned this earlier. So if you're using paperclip, which is a great example, you'll interpolate values like :ID. So you've recorded in your VCR file the upload of an image through paperclip, and it, in the VCR file that says post to /some ID /some name.png. Now someone goes to run the specs and they've got dummy, they've got dummy access key ID and dummy secret access key, and all of that part of the request matches. But the URI doesn't match. So what's VCR going to do in that case? It's going to try to reinitiate the conversation with S3 because it's a different URL. Well, that's going to fail because these aren't valid. Okay? So what you want to do is you want to detect this case where someone's trying to access the same file as the one you recorded your VCR cassette for, but the ID is different. As it turns out, VCR has a facility for that. It's called register request matcher. So in this really, really simple example, I've created a request matcher called path without ID. And this is moronically simple, but it's just to illustrate a point. If I've got /ID/name.jpg, PNG, and I split it on the slash, then the 0th element is an empty string, the first element is the ID, the second element is the name of the file. I want two requests to be considered as identical, but the names are the same. I don't really care what ID it is. So in this very simple request matcher, I'm taking two requests, and I'm just looking at the name part. They're the same if the name is the same. So in that case, all of a sudden, my VCR cassette matches for any request regardless of the ID. So there'll be a little bit of this that you have to do in cases where the URLs that you're interacting with are based on non-deterministic data, but it's really not that hard. Once you've got this request matcher, you just say, when you're running your spec, assuming you're using RSpec, match requests on, and the default behavior of match requests on is a method in URI. A VCR cassette matches it's the same method, get, put, post, the same URI, but you say actually not URI, but path without the ID. Okay, or it really should be called URI without ID because you need to look at the host name also. Sorry for missing that. You'll need to do this in order to actually make it so that your remote conversations never trigger for non-deterministic URLs. But once you do these two things, clear out your old history and make the URL matchers work, now you can push the whole shooting match up there, and people can literally, with a dummy secrets file with no real valid secrets in it, download your repo and type RSpec and actually test your code, and it will work. So, figured this might be useful to someone if anyone's interested in sharing stuff with other people, not giving away their keys. So, I'd share it. So, any questions about this? Yeah?
Have you ever rewrote your Git history such that you can maintain it?
You could do that. In the project that I'm working on, we have about 4,900 commits. So to actually sort through where things are exposed would be
fair enough.
a Sisyphean.
Yeah, there is a GitHub tool though to help you with the rewrites.
Yes, absolutely. In a sufficiently short history, you absolutely
Yeah.
do that. And one of the benefits of that, which I'm sure is what you're getting at, is that a rebuilt history doesn't lose all of the other context about why those commits were made. Yeah. So I was being a little bit over. This is the Howitzer version of how to solve it. But you're right. You could do that also.
I have a question.
Yeah.
Are you going to show us the actual spec running that you changed and removed the secrets from? Like running and passing without using your secrets? Or is that not part of the
Well, here's what would happen. I would type RSpec, and then it would print out a bunch of names of specs, and then it'd say they all passed.
Are you sure?
At this exact point, it actually wouldn't, because I was doing a little bit of refactoring on it tonight, and I broke something before this meeting. No real big problems. I wasn't planning on giving a demo. Thanks, Cal, for putting me on the spot. But I would say, actually, one unexpected side effect of this is actually there were more conversations happening, in my case with AWS, than I even realized. I had examples in my spec files that were communicating with S3, only to discover that the URL they were requesting was incorrectly formatted and they got a 403 error, and then it continued and did something else. But those failed connections from Malaysia to US East 1 were taking all sorts of time, only to do nothing. And when I actually put my URL matchers in place, all of a sudden I'd shave 4 minutes off the runtime of my spec body. And I was like, oh, that's a bonus. Everyone on the team is going to totally love me for that. So yeah, that's a benefit that has nothing to do with secrecy and has everything to do with just master specs.
Have you ever saved your secrets in a database of some sort?
I have. And that could be
Like a service or something.
Yeah, that's a thing you could do for sure.
Have you considered? Or?
Yeah, no, it's orthogonal to this. The reason that a file is nice is because within the team it's easy for people to use. Certainly in other environments we have had secret information, data-driven secret information, because the number of secrets was so large that it wasn't practical to do it any other way. Yep, absolutely. And so in that case, what you'd have is an initializer that bootstraps some sort of information to get to a database where it would read everything else.
Do you know any tools that do this at the moment? Or any source ones?
No, literally the last time I looked at that problem was 11 years ago.
It's called bash script.
Yeah, exactly. Small bash script. Anything else? Okay, great. Well, thank you very much.
Thank you. Alrighty, last but not least. Hello everyone. Okay. So, I'm Guri. Here I'm talk about API documentation with Swagger. So, start. So, my story. I worked part-time before the project, and then we require different teams on different locations. So we have India team that works on UI, so website, and then we build on Rails API. So we have a lot of back and forth. So the API is not complete. How to use your API? A lot of stuff because it's time zone also. So on the next day we reply, and then another time zone he'll reply again. So this takes us a lot of time. And then we start with a static documentation, which doesn't cover a lot of cases, which looks like this. So it's like a curl to the API, and then get some response, and you use that stuff to move forward. Doesn't help. So I'm looking for alternative until went to one of the Ruby Tuesdays in MindValley, and then someone showed API documentation using Swagger. So that's the time where I start looking into Swagger. So what is Swagger? So Swagger is so far it's one of the world's most popular API tooling, and it's open source to Apache. And you can visit this website and you can look at it. So it also uses Open API specification. So it's a standard for doing API specification. So it defines a standard language agnostic interface and RESTful API. And then it allows end user to understand the service without access to the source code. And then it allows user to interact with the remote service. So this is some of the concepts. So let's look at the code. So this is the library. I'm using RSpec, and then I pair with RSpec Rails and factory board. The way I write my specs is something like this. So it's like normal RSpecs. You describe, and then do a before. And then this is the format that you need to do in order to generate your documentation in Swagger. So you will have the path, the type of the request, post or get, and then the tags, whatever tag you want, consume and produce one. It also looks at the headers, the parameters that you want, So you want some parameter in your body, and then the properties that's required or not. And then just let your response, you define whatever response you want, 200 for one, and then just run test. So to run it, basically, just do this. So this first. Okay, MySQL. Connect to my Docker first. See MySQL. DB create. Let it run first. Let's run this back again. Yep, it's running. So this allows you to write RSpec and run it, and at the same time you're able to see your documentation in your app. So this path is generated by Swagger. Okay. So all this API is generated for you after you write the RSpecs for Swagger. Then the user part is here. So just now what I showed is sign in. So for communication wise, if you want your team in other parts of the world to try out your API, all the stuff is here. The required fields is mentioned here, type of validation, and then you can try it out. So for now, we have these cards and the things say required. And let's see if I do something here. So and then it returns stuff from your API. So it's very easy to use, and it enables you to write tests in the same time write your documentation for your API also. So you don't have to do multiple works. You don't have to write specifically for your API, documentation wise, and also test. If you do it once, it works both ways in terms of tests, in terms of documentation. Another thing is how to generate your Swagger. So basically, after you edit the stuff, edit your documentation, you need to do this command rspecs Swaggerize. So it will generate all the JSON consumed by Swagger, so that you will have this beautiful UI. And my test is simple. It's just run test. If you don't want to just use run test, you can actually write something like this one. So something like this. So you run test, you get a response, you can validate your response. So it's actually just integration test here inside stuff inside RSpec and stuff. There's another gem here, but I haven't tried this one. This is Swagger Docs. It's using Swagger also, but it's more towards the documentation. So you need to write documentation in your controller. It doesn't include test book. So and profile. Yeah. So if you do if you have authorization stuff in your Rails application, you will need to do some headers, right? So you need to generate headers. For me, I'm using device API gem. So to do this, you need to have auth header, like this, where you have the access token, you have the client, you have the UID, and then you need to generate your access token from the Rails app. Here. So you create new auth token, and then you have the auth token, and then you just use it and pass it to a header. So it works for your tests, because your test still needs to require user login, right? So you simulate your user login, and then just run the test using the headers here. And then all this is profile spec. So this is part of profile. Profile. Yeah, it will say here, these fields are needed in order to continue. It doesn't say required because you can use it without this, and still allow you to do it. And then there's samples, there's hashing. Yeah, it's quite convenient if you want a fast API doc out.
Can I ask you another question? There seems to be some implied color coding. What is that based on? It's just method?
Yeah, just method.
Oh, okay.
So, yeah. So the Swagger JSON is only generated when you run the RSpec for the first time, and it generates the thing. When you run RSpec, it just runs the test. It haven't generated. To generate, you need to run this command. Swaggerize. Yeah, Swaggerize. So it will have the JSON generated from the RSpec. So all the tests is here in the integrations. Wait, so you write your specs? Yeah, write specs. And then you run Swaggerize. Then you will generate all the JSON from your existing spec. Yeah. So it's just it's like it's just running your specs and figuring out whether there's any posts or gets. Yeah, it's based on your RSpecs, how you define the test, and then you will generate the documentation for your test. Is there any special like DSL that I need to use to call certain things on your RSpec to trigger this, or is this normal like RSpec controller like gets or posts or? Yeah, normal RSpec controller actions. Because all is in previously it's like Rails. It doesn't say anything, it's just normal, yeah, and then just run it. So it's also generated at this. You can configure this in routes because it's just an engine. Should we scroll a little bit? Oh, okay. Oh, that's the DSL. Okay.
Does the test data that you are using also affect the example data that is being shown in the documentation?
So the documentation, it links to whatever your app is running. So if your app is in development mode, you will use the development database. It won't use the test database. So,
but I mean, you had there was a section for example. Payloads that you can use for post, for example.
Okay, I get it. Something like this one. This is type.
Those are just types, yeah.
Types.
Okay.
So it's keeping the autofill for you, and then
Right, so if it's an int, it shows you 0. If it's a string, it shows you a string, a string. Yeah.
So it allows you to know what type of input it expects.
I thought it might be using your test data as well. That would be cool.
And it gets that from your test data, right? Yeah. Whatever you pass it will generate the example value type thingy, right? Correct. So, okay, alright. And I guess the parameters and all these are the DSL, so. Yeah. Okay. Something like this. Okay, this is the DSL, the parameter DSL.
So to state the really stupidly obvious that just dawned on me, the way this differs from other approaches with Swagger is instead of decorating your code, you decorate your tests.
So you
It
have
finally clicked to me why this is different, because a lot of other uses of Swagger, like, especially with Java programming, you write comments above your code, and Swagger generates the UI from that. Here it's just your specs.
So
That's nice.
So it covers your test and your API documentation. Rather than just API without a test, but you do the whole work to make it work.
How are you using? What tools are you using for your API controllers and? Or are you not using any?
You're not using anything. I'm purely rely on the aspect.
Does it support Swagger 2?
Swagger 2. Use this aspect.
Swagger 3 is the new one.
Oh, Swagger 3?
Yeah. Called Open API 3.
I think the syntax doesn't change much.
It changed a lot. For 3, it changed a lot.
Change a lot.
Yeah.
Okay. So
It's called Open API 3. For the 3.
if you're in API 3,
Yeah.
there's two where you can do. There's an online editor.
If anybody's looking to do a Swagger-related project, search.gov has an help wanted open source request for people who are interested in this for the I14Y repo. Come see me. I'll give you a pointer to a great place to put API, to put Swagger into a highly used API.
So they support a lot of other languages, not just Rails. So they have Java, Erlang, just whatever you find it here.
So I've always found Swagger tempting use for API documentation, but my team were heavy, like we use the JSON API spec a lot, like not JSON APIs in like a JSON API, but the JSON API spec that you can find on JSON-API.org. So the thing about Swagger is it's very opinionated about format, and you have to use the Open API schema.
Correct.
That's mainly the primary reason why we don't use Swagger. In fact, we just use Google Docs. Because Google Docs has a collaborative feature, like written collaboration, so you can like comment and for like API clients from other companies like coming over and commenting on the doc. And it's something that I've only seen in Jira. I think a new version of Jira, not Jira, but Confluence has real-time collaborative features with real-time commenting.
Or on the API.
In your Confluence wiki. But we use Google Docs for reasons. Simple.
Yeah, it's one of the alternatives, but any things that works for you, works well. Because this is Open API 3.0, it sticks very deep into the standards, the specification, which is they try to make it into a standard like RFC. I'm not sure anyone has looked into this standard. There's a lot of things can be configured with the objects. Yeah, do check it out. If it works for you, help you a lot. I used to use Swagger with Grape, which is a framework for writing JSON APIs, and you just use the Grape CSL, and the gem will just create the Swagger JSON for you. So Grape.
Got one question. You know how in your your specs, you actually you had explicit verbose examples of your request params.
Yep.
And the body of post.
Correct.
So my team, we use this gem called JSON matches. It lets you put your JSON schema, define a JSON schema in a JSON file, in a JavaScript object.
Okay.
And it follows this schema called JSON schema, which is a spec not for your API, but it's actually a spec and a standard for documenting your API. So the JSON object looks like, let's say user ID, and it doesn't say like 3 or 4 as an example, it actually says integer, and then name, and then string on the other side. And so I'm wondering if with RSOID, can you like link to the JSON file, or does your body have to be in the spec itself?
There's something on the Swagger configuration. Not sure whether. Not sure about that, but there is some configuration that you can set to use other things.
Right.
Yeah.
Might be.
Here.
I have another question. I'm curious, how many people here have used GraphQL? I'll take that. Right. Because like your documentation and all this, it's great. I mean, but another format for web requests is also using GraphQL, and I think that's a lot better defined. Your parameters, string, yada yada yada, over this. I'm curious, the crowd who's used it in production, maybe even.
You were doing something. Any more questions? Any more questions? No questions? Jason? No questions? Okay, great. Thanks. Give a big round of applause for Louis. Great stuff tonight. That's all for today for talks. So now it's time for 5 Ruby tips. Again, 5 Ruby tips is a session where any one of you can just come up here and share something very quickly, and the floor is open for you guys. Any takers? Anybody want to share some Ruby tips? Yes? No? What? No? Nobody wants to share anything?
Do you know about JQ?
Huh?
How many people use JQ?
JQ.
JQ, the utility JQ?
Yeah, exactly.
It's amazing. Okay, so it's not technically a Ruby tip.
No problem.
JQ is a tool that allows you to basically, it reads in on standard input, a JSON document, and allows you to just filter out parts of the document based on a query selector, sort of like a CSS selector.
Yeah. Oh, okay.
So it's
yeah.
awesome. So when you do API requests, you can, even if the JSON's unreadable, you can filter it through JQ saying which subset of the JSON document you want, and it will pretty print it and dump it out to the console. So it's a really fantastic tool for developers to pull out what they need, and you can recall it. You can just like up arrow, hit return every time you edit your API or whatever, and just see that the data is right without having to read some huge blob of data or hit reload in your browser or whatever.
I hit this link before, but I can't remember what I used it for.
And it's generally available as a package, so just apt-get install JQ on your favorite servers or whatever. I use the heck out of that on my projects.
Yeah.
Okay, that's one.
Yeah, that's one. Yes, number 2, come. Yes.
There's a library called Storybook. If you look at Storybook in GitHub.
Yeah, the UI.
Yeah. So this one, it allows you to use React components and show it. So if you search for Storybook Airbnb is a live version of Storybook. that you can just use if you want. Yeah. So they have it, some components here, and you can use it from Airbnb. And you can just run it and try it out.
So
good for UI.
Yeah. Just great. There's no source code for this?
Sure about that.
Yes. Right.
Is it
It's not.
Git? Yeah, they know it's Git. It's this.
What's this one? No, the Airbnb story.
Oh, for that one.
Yeah.
Hmm.
I guess I can show an example of story. Storybook.
You guys use the message, right?
Yeah, but not anymore. We just use Cypress now.
Oh, yeah, the
It's storybook.
Yeah, storybook. That got already.
Okay.
Oh, you have a story sample?
So,
I need a new one.
3 more years.
So yeah, you define stories, and basically these stories are you have the fixtures that goes into your component, and then you just define the component loaded from your app source itself, and basically you have this, and then you have this nice interface to go through them, and these are actual components, and that's why it's a documentation plus integration tester. So yeah. Nice. Number 3. Anybody? No? No.
Well,
Yes.
Yeah, you might want to check out the gem I mentioned earlier. It's called JSON_matches.
Oh yeah, I was opening it.
So this is a spec that my team uses. So it's an alternative to Open API, but also the reason we can't easily use Swagger. I think a couple of forum threads out there about people also using the same spec but trying to use Swagger with it. I think there are a couple of solutions out there, but we've never really pursued it, and happy with our Google Docs now.
Okay.
But I think one thing that's cool about that presentation here is the ability to actually update your doc in your CI simply by using a tool. So if you have that read command that's part of CI, have it generate your docs and then update it into a different, get it posted somewhere automatically from every successful build on production. That would be really cool. But yeah, JSON matches, check it out.
Yeah.
JSON_matches. So this tool we use to define our spec, our API request bodies and the params in the specs itself. It was getting a bit really messy because some requests you simply just have a really huge body, or you have a lot of params. So this kind of tidies it up because you move that whole chunk over there into a separate JSON file. You put into your spec support folder, and then you link to it in that example down there. Yeah.
So you're just defining the type, the things that you want to match with, and match it with this schema definition instead of actual exact data.
Exactly. Yeah.
Okay.
Oh, but you can actually send in data using like Retrieval or whatever. You send it in, but then it matches in the type in there, in the field, in the JSON example. So the type says string, right? But you can actually you can use regex in there or stuff.
Sorry, you can use?
You can use regex in there.
Oh, okay. Right, type. Cool. I guess to your question just now, whether you can export this out into, I mean, you can always repass this into an object that can be put into the Striker.
Okay, that makes sense.
Cool, thanks. So what, number 4? Anybody? Anybody? Robert? Anybody? No? Nobody? 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 Okay, if there's nobody, then we can end this early. So today is three movie tips. Not 3 tips. I should change this title. Anyway, so alright. And okay, so before we head off, again the floor is open for hiring shoutouts. Anyone wants to do a hiring shoutout here, please? Yeah. You can sit up and then you can address the crowd.
So like our company, Toll Plus is looking for Rails developer.
Toll
Plus.
Yeah. How do you spell that? Toll I don't want the Toll Plus. So you guys are hiring what?
Having like 2 years developer.
Rails developer.
Yeah.
Any like seniority or anything like that?
We don't have a career.
Oh, you don't have a career HR. So your contact information or how do we get in touch? Or is there an email or anything? Career at tollplus.fly or anything?
We don't have that. You guys can just ask here.
Sorry, your name is? Fikri. So anyone who are interested in those 2 Rails developers, please look up for Fikri later on. Great. Anybody else? Hiring shoutouts? Hiring shoutouts? Well, I guess
just now
already. What was the
Flingbond, looking for contract work, front end, mobile developer.
Flingbond is like a dating app, right?
Not really, but
It's a dating app.
it looks like it, but it's not.
Okay.
Yeah,
Alright, so if you're interested to be a front-end developer for Flingbond, look for Green. Okay, then, and I guess that's it for this meetup. So thank you for coming, and hope to see you guys next time. Thanks. So yeah,